Alright, you're going to be learning about derivatives today. This is going to be a standard equation that you can find in any calculus room. So, to find the derivative, it's pretty simple. You're going to move the exponent, right here. You're going to move it up in front and lower the power by 1. So, you got to do the y prime because that tells you it's going to be a derivative. So 4x to the third, you're going to do that all the way down the line. 3x squared plus 2, because there's no exponent, so the x goes away, and then this is going to be plus 0 because 1 just goes away because there's no x. And then to find the second derivative, you're going to do the same exact thing again. 4 times 3 because you're moving it down. 12x cubed plus 2 times 3, which is 6x. It's just an x because it's cubed, so you take 1 away. And then it's going to be plus 0 again because it moved down from a 2. Now it's just a 2, so now it's a 0. And these help you find the position, which is going to be the first equation. We're just going to write p, ran out of room. And then it's going to be velocity. And then acceleration is...
I was checking to see if you were awake, okay? You did accelerate throughout this whole time. Your acceleration was just constant. So you were constantly speeding up, running faster, because Stacy's catching you, okay? She's catching you. And you were accelerating at a constant rate of 2, okay? So you got away from Stacy, but
Okay, so in order to take the derivative of this, do we use the quotient rule? Do we use the product rule? Okay, so we're going to use the product rule, which is y prime equals first times the derivative of the second plus second times the derivative of the first. And in this equation, this is your first, this is your second. So y prime is going to equal, first is x cubed times the derivative of the second, which would be 4x, plus the second, which is 2x squared, times the derivative of the first, which is going to be 3x squared. So then you're going to multiply the terms on each side of the equation. So this one would be 4x to the fourth, plus this one would be 6x to the fourth. And since each of these x's have the same exponent value, you would add these for 10x to the fourth, and that is the derivative.
Okay, so on this problem, we're after the chain rule, and it's a little different, but how you start is you got to grab the exponent on top, bring it to the front, so it'd be 2, and it's times the original equation. It'd be x squared plus 1, and then times the derivative of what's inside. And it's 2. The x squared goes to a 2x, and that turns into a 0, so it doesn't multiply by anything. And then you just have to multiply this out. 2x times 2 is 4x times x squared plus 1. Then you just multiply these. It should go to 4x cubed, and then be plus 4x, and that's how you do the chain rule.
Alright, I'm about to tell you about the meaning of derivatives, so pay attention, only happen once. Alright, so right here, our original equation is what we call the position. Okay, this is our position equation. Now I'm gonna put this in the real world terms right now. So let's say we're sitting here. Our equation, our position equation, is going to show us where we are at in relationship to the origin right here. We're going to say this is Stacy's mom's house, okay? That's Stacy's mom's house. Now that right there is going to be 0, 0, as y'all can tell. So to explain this, we're going to say Stacy came home, saw you with Stacy's mom. Okay, so you had to dip. Now, at 2, where x equals 2, we are going to show where you would be in relationship to this house. So we're going to put that back into our equation. So it's going to be 2 squared, because you plug in for x, you are 4. We're going to say it's 4 miles from the house. Stacy can't run that far. We've been known this, okay? So you're gone. You're safe. Now, here we go. We're going on to what the derivative of that is, which is your velocity. That's what that means, okay? Take derivative. Alright, so taking the derivative, we know bring down the exponent up front and drop the exponent by 1. So now you got 2x. So let's clean this up a little bit. 2x is going to look something like this. Whatever. That's what it looks like in graph situation. So that is how fast or whatever you're going from Stacy's house. So again, we're going to plug in 2. We're going to see how fast you've been running. So we're going to put it back into the equation. So then we got 2 times 2. Now, coincidence, it's whatever you're going for MPH or whatever, and the direction of that direction, because that's what velocity is. And so you're kind of slow. We're just going to say that. So this right here, to confirm, is your velocity. Now how the second derivative fits in here is that we're going to find your acceleration. So it's double prime right there. We take the derivative of the first derivative, that's just 2. So your acceleration the whole time, I'll write that out, is the same the whole way through. So we're going to say it's 2. You did not speed up or slow down. You started at that acceleration and you finished at that acceleration. So that's what that means. I was checking to see if you were awake, okay? You did accelerate throughout this whole time. Your acceleration was just constant. So you were constantly speeding up, running faster, because Stacy's catching you, okay? She's catching you. And you were accelerating at a constant rate of 2, okay? So you got away from Stacy, but